Good afternoon, everyone. Today, I'm excited to introduce high-speed autofocus and depth perception using pixel-level computing image sensor and liquid lens technology. Yeah, I'm going to talk about two technologies, the pixel-level computing sensor and liquid lens. By integrating these two technologies and for the algorithm inside the sensor with the processor inside, we can have a lot of application with rapid focusing and the image processing. This one? Oh, okay. Let's see the image system. Traditionally, or we say usually, to have the object to get the image, we need to have the image system including the lenses, camera, and the processing unit, or usually we use PC. For this case, if we need to adjust the focusing, we need to have the motor usually. So that when we take the picture, that the light goes through the lens to the camera, inside the camera, the sensor gets the image, then convert the analog signals to the digital data and send to the PC. Okay, after some algorithm to calculate to get some features, and then that software might decide to adjust the focus. To adjust the focus, the PC send command to the motor, and then motor move one of the lens element inside the lens assembly. Okay, that is the traditional one. And then we can have some improvement. We can use the liquid lens to replace the motor so that we still can have the focus adjustment. And with this solution, or we say the improvement, we can save power. Because that without the motor, we use the liquid lens. The liquid lens is not a moving part. It can save power. It can have a rapid response. Okay, that is pretty good. Furthermore, we can have we call that the pixel level computing sensor. For this one, we can get the computation into the sensor so that when we take the image, the computation happens simultaneously. Okay. Okay. And to have this design, we got the inspiration from the human eyes. And we can see that with the computation with the pixel level that looks like the human eyes to adjust the focus and get the image and to recognize the image immediately. Okay. That is the structure of our system, and I'd like to talk about the heart of this technology. That is the pixel level computing sensors. Okay, so still start from the conventional computing architecture. We can see that when the sensor get the image, convert the analog signal to digital data, then send the data to the PC, and in the PC, the data are stored in the memory first. Then the processor need to get the data from the memory, process and restore and get and back and forth many times, so that we can see a lot of the data transmit between the sensor and the processor and the memory. So we can have some advanced design. That is to put the processor close to the sensor so that it can reduce the traffic from the sensor to the post-processor. And it can do some necessary computation in advance. Okay. And of course, we have the improvement a lot to the front end. That is to put the processing with the sensor together. So we can see the drawing right side. Here we can see the image sensor aside with the processing unit. That means every pixel has the processing unit with it, so that you can find out that there are a lot of the processing in parallel. That is our architecture. That means we can get the pixel and with the computation simultaneously. Okay. Okay, we have the sensor already, and we talk about when we try to adjust the focus, we still need the optical component, and we use the liquid lens to replace the motor moving parts. The basic idea of the liquid lens is the phenomenon we call electric weighting. Okay, so you can see that there are two different liquids. One is water, and the other one is oil. As we know, water and the oil, they will not really mix, so that they can consist of a surface. Okay. And because of the refractive indexes of oil and water are different, so that we can get two materials with different refractive indexes, and in between there is always a surface there. So when we put the different voltage, we can push or pull this surface, and then it can change the curvature and to come out a spatial surface. And you can see that because of this surface, when the light go through this, it will, depending on the refractive index, it can be just like a divergent lens or flat or convergent lens. So with this, it is a variable lens. Using the two different liquid, it works as a variable lens. So we can put that into a lens assembly and get the high-speed focusing and very compact the tunable focus lenses. Of course, because it has no motor, so that it is a very low power solution. Okay, when we have this liquid lens, usually we drive the lens to different shape. We change the voltage. According to this joint, you can see that from the time and the optical power change, you can see that when the power applied, it changes very rapid, and then that is a little bit kind, we say, overshot, then go to smooth. Usually we wait till that smooth area, or we say the stable period, we get the image. But here we introduce the advanced method to get the image rapidly. That is, we use the oscillation period. Okay, so that even before go to the stable period, because we can catch the right position. You can see that. Okay, just about maybe less than 20 milliseconds, the optical power is almost the same as the stable period. So we can get the image over there instead of like 80 or 90 milliseconds. After getting the images, because this is the pixel level computing sensor, so that we can have this so-called edge detection immediately. To introduce this algorithm, it is really suitable for this pixel level computing, because it converts this pixel with you can do that in a small area and get the result immediately. So this is one. Okay. That is one of the application, and because of the pixel level computing, so that you can image, we can implement a lot of the algorithms, and we can find out some algorithm is really suitable for the pixel level computing sensor. Here we are going to introduce two kinds of the application. It is usually, or we say our customer are using. The first is the edge detection. Just as I showed on the previous page, when get the image, we can do the edge detection immediately. So that here's our test data. We set the T0 to time 0. Then next picture is T1, that is 2.075 millisecond. From T0 to T1, just a little bit more than 2 milliseconds. Our sharpness is from 990 to 6,941. Another 2.08 millisecond, we got more than 10,000. I mean, the sharpness index. So here we can see it is a little bit more than 4 milliseconds. We get the edge. For, we say, the traditional image system, in 4 milliseconds, it is only about to get the exposure only. We even, I mean, the PC has not received the image yet. Okay. The next is the global focus. The global focus is like this. We might have the object with different surface, different height of the surfaces. And to get all of these different faces to one picture, we can use this technology we say the global focus. Okay, that is to take 1, 2, 3, 4 pictures, and every one of them has a partial clear image, that is a focused area, because the surfaces are different distance from the sensor, so that some of them are blurred. So combining these 4 images, combining these 4 images, we can get a complete clear picture. And the most important is we using our technology, we can take these pictures rapidly and computing rapidly so that we can get the complete clear image immediately. So our system has these advantages. That is, we use the liquid lens and in the oscillation period to have the best focusing. And we can have the full range autofocus technology, as I just mentioned. Of course, high-speed evaluation because of the pixel level computing. And that is the seamless system integration. That is our technology. We will say that to combine, to integrate this to the innovative technology to let us have a complete solution with rapid and the low power and the high performance. Okay, so that I'd like to introduce some application as well, or we say our working experience here. This is similar to the previous one, to take the pictures in different focusing, and take like this one, we take 4 pieces of the images and get the best one. Okay, here is a very different, or we said a very exciting application. That is to use this technology. We can know the focal length and we can know the image distance, because the image we can use the pixel level computing immediately, so we know the image distance. I mean the image between image, and then we use the Gaussian lens formula. We can get the object distance, so that using this one we can take pictures and got the object distance. The right side you can see that we using the different color to show the different distance, and that is our solution. And okay, here is my contact information, and welcome to send me email or drop me any message through WhatsApp. Okay, thank you.